Hi, this is Django. In this video, we're going to cover the GasbotV2 contracts. I'm just going to walk through and talk about like everything that's important. I'm going to take you through the Gasbot UI just to give you an idea of what Gasbot actually does and just give some background to what you're going to be seeing in the contracts. So I'll start with that from the UI. So this is Gasbot V1 and the audit is for Gasbot V2. V2 is exactly what V1 is, but it also adds an extra layer, which I'll get into. So V1 is a good thing to familiarize yourself with just to understand what Gasbot is actually doing. So the whole purpose of Gasbot is to make it very easy to get gas on any chain. So cross-chain gas is its only function. And it does that in a couple ways. In V1, it allows a user to take their stablecoin, as you see, and basically just give us access to it. We'll take it and we'll send them gas on whichever chain they want. For example, Polygon USDC.E. So you can say like, give me $2 worth of gas on, let's do Phantom. And basically from here, there are two branches, right? This stablecoin supports the permit function. So a user will just click sign permit and submit. It's going to sign a permit message. It'll sign, I'll just go ahead and go through with that. It signs the permit message, and the moment we receive the signed permit message, we relay the function call on the first chain, and then once that's confirmed, we transfer out the gas on the destination chain. So no user transactions in that entire flow, and it will give you both of these transactions to view on the Explorer. So that just takes about like 15 seconds or so. And then the other flow that we have is for stablecoins that don't support permit. It's kind of a normal approval flow. So for example, BSC. I'm already on Polygon. I'll choose a Polygon token. Oh, that's interesting. I don't know why we have two there. Let me refresh. Little UI bug. So I'll actually do the BSC one. So for example, give me $5 worth of BSC gas on Polygon. It'll probably ask me to switch chains real quick. And basically the only difference is instead of signing a permit message, we're sending an approval transaction. So once that approval transaction is confirmed, Gasbot is going to do the exact same thing of relaying the call on the source chain to take the stablecoins. And once that's confirmed, it'll send the gas on the destination chain. So where V2 is different is we're going to allow gas swaps. So if you're familiar with like Bungie Exchange, is basically send us gas on destination or on chain A, we'll send you gas on chain B. So for example, you send us Matic on Polygon, we'll send you AVAX on Avalanche. So the reason why this requires an audit is because in V1, every external call, every external function is permissioned. Only our relayers are able to interact with the contract, but adding the gas swap adds an external function that anyone can call. So just kind of want to make sure we have our bases covered and make sure that there isn't any room for any vulnerabilities in that. So at this point, I'll take you through the Gasbot V2 contract, just give you an overview of what's going on and how some of these functions look that we just saw in the UI. So Gasbot V2, these are the important variables that we have in the contract, not many. We have the owner, who will be set by us on the in the constructor. We have relayers. So this is a mapping that is basically the only people that can call most of the functions in the Gasbot contract to take tokens, send gas, or whatever. We'll talk about this one. This is replay protection on transferring gas. So these variables right here are important because on each chain, since we're deploying to so many chains, for example, currently we support 12 different chains here. We have to deploy this contract to every chain. So we need to know their native address, their native wrapped native address. For instance, WETH on Ethereum or wrapped Matic on Polygon. We just call it WETH in our contract. The default router, this will be the default Uniswap router that we're going to use to swap between what we call home token and that wrapped native. A distinction of whether or not that's a Uniswap v3 or Uniswap v2 router. It'll be true. This will be true if it's Uniswap v3, false if it's v2. Home token. So each contract is going to hold one token, and that's the home token. For example, if we go back to the swap that we initiated on the transaction, we'll just go in and see the current V1 Gasbot contract. So you can see on Polygon, this holds 263 USDC.E. That's the home token of this contract. That's basically the liquidity that this contract has. So if someone were to come in and swap Avalanche USDC for Polygon gas, they would send their USDC to the Avalanche contract, and we would take this USDC-E on Polygon and swap it to gas and send Matic to them on Polygon. So this represents the liquidity that the contract has. So each contract is going to have a home token. It's mostly USDC, like native Circle USDC. On Polygon, as you saw, it's bridged USDC-E. On some, I think on BSC, it's USDT. So that can vary. Default pool fee. So in case the default router is a V3 router, we need to know the default pool fee to swap through. So that's set at 500 on deployment. So there's our constructor. We have a couple of modifiers. So several only owner functions, several only relayer functions. And then this is the kind of meat of this contract. So the first function is called relay token in. You can think about this function as this is going to be a cross-chain function. So using the example we just walked through, this one, we're relaying tokens in. We're relaying that stablecoin in on Polygon, and we're transferring gas out on Phantom. So we take their USDC on Polygon and send them gas on Phantom. So in this flow, we called relay token in on Polygon. So these are all of the necessary parameters. So what token did we relay in? That was USDC-E. We needed proper permit data in order to gain access or allowance to that USDC. And then we have these 3 parameters. So we need Gasbot to be flexible in that when we start adding support for more tokens, we may need to use different routers just because we're going to use a lot of different dexes. And those routers may be V2 or they may be V3. So we supply custom router, custom UniV3 path, and custom UniV2 path. So only one of these paths will be usable. It just depends on what we're sending. So like if the UniV3 path is not empty, we can just assume that this custom router is a V3 router, and vice versa. And then a min amount out. So it's important to note that this is only called by a relayer. So it just kind of follows a flow that's pretty easy to understand. So permit and transfer in, uses the permit data to grant us allowance to take it, and then we transfer it in. If it's not a permit supported token, it's just an approval token. Basically, the caller will have to send that approval transaction firstly, and the permit data that we send in is just going to be blank, or the signature is going to be blank, and we'll just ignore that, and you'll see that in the private function. If the token that they're relaying in is the home token of the contract, we don't need to swap to the home token, so we just return from there. But if it's a different token, for example, Polygon home token is USDC-E. If we had relayed in USDT on Polygon, we need to swap from USDT to USDC-E. And then we pass in all the important information for the pass and the custom router. So that's the source chain relay token in, and then the destination chain transfer gas out, also only called by our relayers. We have this parameter for replay protection, and that's replay protection, just kind of accidental replay protection. In case we accidentally call the same function multiple times just on our back end, we want that not to be possible. So we just have a quick require, make sure that outbound ID hasn't been used. And one distinction here for kind of how the swapping is done. Well, let me just back up. So the swapping that needs to occur here is we start with the home token, specifically just to give you more context. On Phantom, on our Phantom contract, our home token is Axeler USDC. So when we transfer gas out, we will be starting with our home token and Axler USDC and swapping to wrapped Phantom, and then finally, or unwrapping that Phantom and then transferring at least the min amount that we had called to the recipient. So since we're only ever going from home token to wrapped Phantom, we can just use our default router and default paths. So we have this really useful function, get default swap paths, in order to get just the UniV3 or UniV2 path, depending on what the default router is, what kind the default router is, and just perform the swapping. So no inputs for the routers or the paths needs to occur for transfer gas out, since we know that the home token is just an easy path that we kind of have predefined. And then this relay and transfer function is used for same chain swaps. So if I were to take USDC on Polygon and I want Matic on Polygon, we would call this function. So everything occurs just in one atomic function call. And it's kind of all the same, or what you might expect from like the relay token in function. So you permit transfer in, you swap from home token to, actually take that back. It's not necessarily home token. You can swap from any supported token to WETH, unwrap it, and send it to the user. So it just happens in one same chain transaction. So that's basically V1. It's written in a much different way than V1. V1 was more flexible by using low-level calls. So this is the same functionality, just a different, more transparent implementation. And then we get into what V2 adds here, and it's just this swap gas function. So the idea is anyone can call it. They just supply some native value in their call, and we cache the balance of the home token at the beginning of the call. We deposit the native token into the wrapped version. We get the default swap paths, and we make the swap from the like wrapped token to our home token. Then we check how much added value of home token we now have in the contract, and we just emit an event for us to be able to query later. Basically, the most important part is like who sent it, how much native they sent, and the added value. The added value being, the most important part of this, as well as the from chain and the to chain ID. The to chain ID isn't checked whether or not it's supported, like it's a supported to chain. So because since we're going to support so many chains, we don't want to have to maintain like a mapping of chains we support. So we're going to implement some sort of refund mechanism in order to refund a user who sends this to the wrong chain ID. So the funds aren't just sitting there. This gets us to the internal and private functions that we've kind of talked about, like how the permit and transfer in works, how the swap works, basically just a distinction between UniV3 and UniV2 swaps, unwrapping into native, and then transferring at least. This is probably a good time to talk about how we're sending the native. We elected to use .transfer instead of call. And the reason for that is we're deploying to so many different chains that there seems to be like a difference in just how gas calculations are performed. And I'm not an expert here, but for an example, I just saw swap 168 just before this one is on Arbitrum. And on Arbitrum, gas just is like inflated by like an order of magnitude. Like this is 1.3 million gas, whereas on Ethereum, the same function call is 191,000. So just, basically 10 times. So for that reason, I didn't want to use .call with a gas stipend, like 30,000 gas, because I just wasn't sure how that was going to work on Arbitrum. I figured that using .transfer will just use the correct implementation of transferring native to a user, just based on parameters set within their environment. So what that means is probably you're thinking about like how like contracts who have some sort of fallback or something won't work here. So we just have this notice here just basically saying the caller of this needs to be an EOA or a contract that won't revert. And again, if it would revert, I don't know. It's just like, it's not something that we're going to deal with probably, given that our entire model here is kind of a UI based thing. This has to be an EOA for someone to initiate a transaction through this UI, and we don't foresee many contracts sending gas through the swap gas function that wouldn't be able to support it. So we intentionally are using .transfer on that. That's pretty much everything for like a user facing function. We also have some admin only functions like setting the default router. This also sets the V3 or V2 type, set default pool fee, setting the home token, which we don't foresee using in the future unless there's like a depeg of our home token, or maybe the liquidity of the home token tanks for whatever reason. And then we also can enable or disable relayers. We also have an execute function, basically just an admin only, do whatever we need to do function, and a withdraw function as well here. So we'll have several relayers that are, Gasbot controlled relayers, and we want a very convenient way to replenish them with gas. So we'll just call this replenish relayers function, which we'll pass in our relayers that we need to replenish their gas, the amounts for each of those relayers. And basically the idea is it just takes home token from the contract, swaps it to WETH, and unwraps it and sends the relayers those amounts. And the last relayer will receive at least their amount or any like extra left in the contract. And then finally, there's just a few view functions, get token balances used by the front end. So for example, if we go back to the front end, as you can see, so we're scanning user wallets for all of their supported tokens. So it's just a single view call per chain, just to give us the balances of their tokens in native. And then get relayer balances, just getting the native balances of our relayers. And then get swap paths. So that's what I explained earlier, just getting the default swap paths, either from home token to WETH or from WETH to home token. So that's what the bool is signifying there. So we have a really awesome test suite that we got created by a really cool contractor. And it covers pretty much everything, every like just basic case here for our functionality. So that's a really good place to start when auditing this contract. But that's an overview of what Gasbot does, what V2 is adding, and hopefully that's enough information about some of the decisions we made and the functionality in the contract. So if you have any other questions, I'll be available. Otherwise, thanks for watching and thanks for your eyes on this contract.